Now, my training centre at Tomcat is just literally there on the corner. And as you can see, we are surrounded by lots of flats. So, multi-occupancy buildings. So it gave me an idea. I need to do an ACS revision video on what we're looking for when we're working in flats like this, or even old mills that have been converted into flats. So let's get on with it and find out exactly what we need to know about when we're doing gas in multi-occupancy buildings. Now, the regulations on multi-occupancy buildings are governed on heights or stories. So if you have a flat which is less than 5 stories or 11 meters, we follow one set of instructions. But if the multi-occupancy building is over 18 meters or 6 stories, we have to follow another one. On the 14th of June 2017, a high-rise fire broke out in the 24-storey Grenfell tower block of flats in North Kensington, West London at 54 minutes past midnight. The fire raged for 60 hours, with 72 people sadly dying, 2 later in hospital, and more than 70 injured and 223 escaping. It was the deadliest structural fire in the United Kingdom since 1988's Piper Alpha oil platform disaster, and the worst the Londoners have seen since the Blitz of World War II. Because of this disaster, the Building Regs Document B has been changed, so subsequently the gas regulations have changed, so we will need to follow those when we are installing gas appliances or pipework into multi-occupancy buildings. Now, inside this grey door here is the gas meter cupboard for this block of flats. So let's have a look here. Now, the first thing you notice about this door is there are no signs whatsoever on it to say that there are a load of gas meters behind this door. So the fire brigade wouldn't know the meters were here, or neither would our ESP or any meter readers. So first thing, now the door has to be lockable, which it is. And because it's lockable, anybody who has a meter in here requires a key to be able to get in to this meter cupboard for their meters. As well as being lockable, this door has to be self-closing. As you can see, it's not self-closing. Also, in this wall here, we require ventilation. So let's have a look and see what size vents and how we work out the ventilation for this gas meter cupboard. Now, there are 2 ways of working out this ventilation for the compartment, cupboard, whatever you want to call it for the gas meters. Now, the first way you can do it is 2% of the actual floor area. But if you don't really know the floor area, then they say they can use this chart, which they call the notional floor area, or you're guessing. So, first thing is, if we've got 2 gas meters, it says our notional floor area must be 0.5 meters squared per meter. So if we've got 2 meters, then that means we'll need 1 meter squared of floor area. Now, 2% of this 1 meter squared, this is the way I worked it out. If you can think of an easier way or a better way, then stick it in the comments down below. Maths isn't my strong point, neither is English. But anyway, so this is the way I did it. 1 divided by 100 times by 2 gives us 0.02 meters squared of free air. And then this can be split then between these 2 vents. Or, say we had 10 gas meters, then we would do 0.5 meters squared per meter, which is 5 meters squared. Then we would do this 5 divided by 100 times by 2 would give us 0.1 metres squared of free air, which we would split between the two vents, top and bottom. Now, it does say if you can't get 4 vents, one in each wall, it then says up it from 2% to 3%. So if you've only got vents in one wall, up it to 3%. Now, hopefully, that makes sense. Now you can see flat 6 is written on this meter, but if we go to this meter, there's nothing written on it. For some reason, there's a 94 on there, so that could be going to, I don't know. Nothing on there, nothing on there, nothing on there, and nothing on there. There's actually nothing written on here except for that one flat to say which meter belongs to each flat. So each ECV should be marked up saying whose flat it belongs to, but there's nothing. There's no line drawing, there's no information, there's nothing on here saying any information whatsoever. So this is the meter inlet valve coming up to feed the bank of meters, but there are no signs whatsoever around here to give any information about the meter bank itself like there should be. So this is a good example of a comprehensive composite notice found in iGEM G5. The label for the bank of meters shall be placed in a prominent position and should be within sight of the meters and the ECVs. The label should be provided with the following information on it: actions to be taken in the event of a suspected gas escape, a line diagram, the gas pressures, the equipotential bonding, the security seals, and no smoking and gas escape labels. Now you can see there's also a load of electric meters in this gas cupboard. So this electric side of it has to comply with zone 2. Now I ain't no electrician and I don't know whether all this complies to being able to be installed in zone 2 or not. So if you do know, let me know in the comments below. But as you can see, the fire stops for this room are not very good. So you can see it's not sealed down the side there. We've even got bits of plasterboard missing, and the plasterboard isn't skimmed, so it isn't fireproofed anyway. And if we look round here, at the top here, I don't know whether you can see that, but let's go there, it's actually missing. So the fire resistance for this room is not that good. And as you can see, some of the tenants like to leave their bikes in here. Can you use it as a store cupboard? I think not. And the water meters are also here as well, with the pipe going through. Now you can see there is an electric cable going through the wall there, which isn't fire stopped. There are more electric cables up there, again, which are not fire stopped, going through this room into the corridor. Now let's take a look at the installation of the pipework and the meters. Now the first thing, the main coming in from the street should have an isolation valve on the inside of the meter cupboard. So this is what's called the meter inlet valve. There should also be one in the street as well. So you can isolate it in the street and here to turn off the meters. Also, because this meter bank is going to be internal, the incoming supply here from the street can only be low pressure, so up to 75 millibars, and not medium pressure. So that is the main entry T coming in, and if we follow the dug up bit, we can see there actually is a little access panel to get at the isolation valve in the street. So that's correct. Now when you've got 2 or more meters in a row, they're called a bank. So this is a bank of meters. So this pipework coming in here would be sized by the supplier, and the rest of the pipework here going through to the flats would be sized by the gas engineer doing the installation, or somebody who designs gas pipe installations. So this will say is sized correctly pipework coming off the meters and going off into a ventilated void on the side of the property. So the pipework comes through the main wall. Now this needs to be fire stopped, and also this room needs to be sealed, so if there was a gas escape then it wouldn't go through to any of the flats, it would just go through the ventilation which we've looked at. So this pipe going through into this void, because once it's installed you wouldn't be able to get at it normally, so it would have to be made of steel, which can be screwed or welded, and it could be made of corrugated plastic coated stainless steel tube, because it would be one continuous piece. Well, technically you could get away with copper if there was no joints in it. So I think in this installation you'd struggle. Anyway, we'll look at the sizing of the vents in this shaft a little later on. Now, when the pipework comes into the flat, again, it needs to be fire stopped. Straight after as it comes in, it needs an AECV, or an additional emergency control valve. So you will have an emergency control valve still at the meter, but you will need an additional one in the flat. Now, if they have 24-hour access to the ECV here at the meter bank, then if they haven't got an AECV, then you would advise them to have one fitted. But if they didn't have 24-hour access to the ECV, then no AECV would be deemed at risk. Okay? Straight after the AECV, or within 300 mil of the AECV, we will require a test point. And that is, you could actually do a tightness test from there and test the house or the flat. So you could do one at the meter, or you could do one at the AECV. So it would make it easier to find leaks. So if you did have a drop here, then you could isolate these two and see if it's here, or whether it actually is in the flat. Now, as well as the test point being within 300 of the additional emergency control valve, the sighting of this emergency control valve is also important. It should be as soon as it enters the flat, or as practical as it can be coming into the flat. It needs to be within 450 and 1450 of the floor, because obviously if it's too low you're not going to be able to turn it off, and if it's too high you're not going to be able to turn it off. So that is the requirements for the pipework going into the flats from the meter bank. Remember, this would need to be sized correctly, and this could end up with being oversized for a domestic engineer to work on there, but if you did have your AECV in there, they could work back from that way. So hopefully that makes sense. So what can we use as a fire stop then? Well, if a soil pipe or a waste pipe passes through multi-occupancy buildings, there are specially designed fire stops for them. Because the pipe is made of plastic, as the plastic melts, the fire stop expands. We also have the same with vents as well. We can have intumescent vents which do the same thing. As they're melting, they expand and they close off. But we have this stuff, flue jointing compound. So we can use this on the inside of meter boxes to when the pipe passes through the back. This is the stuff we're supposed to be using. Now this will go up to 250 degrees centigrade, and it does say on the tin here it can be used as a pipe seal when a pipe passes through a wall. I can't think of anything else you could use. High temperature silicone, would you be using that? Again, it probably depends on the temperature and whether local building control will allow it for a fire stop. But at the moment, that's the only thing I can think of to use for a fire stop. Put down in the comments down below, guys, if you can think of any other products what could be used as a fire stop when a pipe passes through a wall. Now, let's go back down to the meter cupboard. I keep calling it a cupboard, but its technical name is a compound or an enclosure. So technically it's a compound. But anyway, let's go back down there and have a look at the pipework and see if it does comply with everything what we've just gone through. Now, they've used track pipe on this installation, as you can see here, which isn't the pipe system. So there isn't the extra sleeve on there. So that means all this pipe work here, if it goes up into a ducting in the flats, it will require ventilation. But if it was the pipe system, then the duct wouldn't require ventilation if it passes through a corridor and then it could be vented into the corridor. You could do that with steel pipe as well. Also, you can see this track pipe has actually been sealed at the gas meters, where in this situation it should be left open, so if any gas does escape, then it has a place to go. So this is what's meant by the pipe system on this corrugated stainless steel tube. So you can see there is actually two sleeves there. So there is an inner sleeve and then an outer sleeve. Now on the inside of this outer sleeve, there are ridges, continuous ridge, which would allow the gas to actually pass through the two sleeves. So they are tight fitting, if you can see, but you can actually just see the little ridges. That gives you a better idea. So this has got double protection. So if this pipe did leak, it would then pass through the outer sleeve and then go back into the meter cupboard where it's ventilated, or should be ventilated, and people would then be able to smell it also. So that is what's meant as a pipe system for this corrugated stainless steel tube. Now, another way this can be achieved using the standard corrugated stainless steel tube, so the one what isn't the pipe system, is you could use this stuff. So this is a flexible sleeve which would have to run the full length of the gas pipe, but the volume of this can't exceed 0.1 meters cubed. So there you go. That's one way of doing it. Now, one product you cannot use in a ventilated duct or a sleeve is this. So this is gas MDPE, and this cannot be run inside the building. This is for underground purposes only. So don't think you're going to get a cheap fix by using this instead of using this pipe system. My advice to you would be always contact your local building control before you're running a gas pipe in a new development. Make sure it complies, and always use this kind of stuff with the pipe system. There's quite a few manufacturers of this corrugated stainless steel pipe system now, and you can pick the one what suits you the best. So bear that in mind. So hopefully you can see here, this is where the trap pipe goes into the ducting, and also there's wires going in through the ducting as well. So are they fire stopped? No, they're not. Now this is the main staircase and landing and lobby for these flats. So this is what's called a protected area. So any gas pipe installed within the stairwell, the lobby or on the landing must be in a fireproof protected shaft, which is ventilated to direct to outside. Now, the track pipe we saw downstairs is installed in this boxing in, which you can see is not ventilated at all. Now, if this pipe is steel, screwed or welded, and continuous copper, or track pipe, what they could have done is just put vents here, top and bottom, because this area, because a high volume of traffic comes here, they call it an occupied area. So if it was to leak, people would smell it. But also what they could have done was put two vents here, and also this wall here is an outside wall, so they could put vents in there as well. So they had quite a few options to do here, and they have run the track pipe, but they've not put it in ventilated voids. But if they had installed pipe track pipe, so what we've already seen, then this would have not required to be ventilated because it's a pipe system. Also, if the pipe is running the ceiling voids in an area like this, so a lobby or a landing or a stairwell, it also has the same requirements. Gas meters are also not allowed to be installed in protected areas. Now, if you're unsure about any of the regulations, what are required when you're installing gas pipes into flats, especially in the protected areas such as stairwells, lobbies and landings, then you can ask the responsible person for the golden thread information on the property. So what is this golden thread thing then? The golden thread involves keeping a digital record of crucial building information, starting from the design phase and continuing through the building's life cycle. The government have decided that the golden thread of a building's information must be stored digitally, but this can be on multiple systems. Now let's have a look at sizing these vents in this pipe duct. Now, one thing to bear in mind is the ventilation, what we're actually sizing, is not there to get rid of the gas if we have a absolute failure of the gas pipe, so catastrophically failing. It's only there if you've got like a small gas leak, and so it allows the gas to escape and so people can smell it. It's the same goes for the vents here as well. This isn't designed for if there was a catastrophic failure of the gas in this meter compound, cupboard, whatever you want to call it. It's just there to warn people and hopefully stop an explosion. Anyway, this is how you do it. Now, for some reason, one, we do it off the cross-sectional area of the duct, and two, they've done it in meters squared. Anyway, if your duct is less than 0.01 meters squared, then you don't need any ventilation. But what is, how big is 0.01 meters squared? Well, technically, it's a little box, which is 10 centimetres by 10 centimetres, or 100 mil by 100 mil. So that is actual size. So if your pipe duct is bigger than that, you're going to need ventilation. Now remember, it's not the length of the duct, it's the cross-sectional area of the duct. If your duct is between 0.01 meters squared and 0.05 meters squared, then we go off the cross-sectional area of the duct. So depending on how big your duct is will depend on how much vent you have, top and bottom. Now if you're between 0.05 and 7.5 metres squared, then it's 0.05 metres squared of free air you need, which is equivalent to 500 centimetres squared. And if you are above 7.5 metres squared in your duct, then you need 1/150th of the cross-sectional area of the duct. So basically you're dividing it by 150 to get your metres squared. So that is how we size the ventilation for this duct. But remember, this is just so it clears any little spillages of gas. It's not there for any catastrophic failure of the gas pipe. That's why we can't have any joints. Hopefully that makes sense. And if you're thinking, I can't be bothered with all that, then obviously you could run the gas pipe outside. It might look horrendous and it might be open to being stolen, but it's a hell of a lot safer. Now let's have a look at gas appliances being installed in these multi-occupancy buildings. Let's first of all take the 5 stories 11 metre flats. If you're installing these gas boilers, then you can use the standard Flue system for a condensing boiler, and that would have a plastic internal flue for the products of combustion. Now if you're going above the 11 metres, so the 18 metres, the 6 stories, it's a different matter. You cannot use a standard flue system with a plastic internal flue system. Now, some of you may remember way back when condensing boilers first came back out in 2005, well, just before 2005. Then we were using this type of flue system, and the inner part of the flue, like we've got here, is aluminium. This is off an old Ideal, but anyway, you can use this flue system in the above the 18 metres because it is aluminium, and according to approved document B, and in accordance with BSEN 13501-1 2007 plus A1 2009, aluminium is classed as an A1 fire resistant product. But we all know what happened to these flue systems. They corroded. So most of the major manufacturers actually make one of these flue systems for high-rise flats. Now Worcester are using the aluminium, but I did find that Keston, on their Keston twin flue system, are using stainless steel, and I have found that Valent are using a stainless steel system too. So some of the manufacturers are using aluminium and some of them are using stainless steel, and they are quite pricey. So if we're in the multi-storey flats over the 18 metres, all the flues have to be class A1 flues, or aluminium, stainless steel, fire resistant, even the lower floors. So you can't do up to the first 5 floors in plastic and then over that then in the aluminium. They've all got to be aluminium. So that's something to watch out for. And again, just remember guys, if these flues were installed pre-Grenfell, then they're not going to comply to these new standards, because these standards started to be looked at in 2018. So you could say post 2018 we're going to need aluminium, but pre 2018 then you would be advising the responsible person about changing the flues. But obviously if you're installing a new boiler, it will need to comply with the new standards. So let's have a look at cookers. The first thing is the cookers have to have flame supervision devices. So basically thermoelectric devices like we've got here on this hob. So it's got to have a safety device, so if the flame gets blown out, it will turn the gas off. Cooker hoses. Now this cooker hose is to BS 669 Part 1. We can't install these cooker hoses in multi-occupancy buildings. They've got to be cooker hoses like this, which is to BS 14800. Now this is a straight through one, which we don't use. You can get ones of these, but these are the cooker hoses you have to use in multi-occupancy buildings to BS 14800. Now, if you do go to a block of flats or a maisonette or whichever multi-occupancy buildings, and the cooker does not have flame supervision devices, and the cooker hose isn't manufactured to the correct British standards of 14800, then you would deem it not to current standards, and you would advise the responsible person to have them changed. But obviously, if you are installing a brand new gas appliance in a multi-occupancy building, easy for me to say, but anyway, you cannot install a not to current standards. So the cooker has to have flame supervision devices, and the cooker hose must be to 14800. So that's my look at the installation of gas appliances and gas pipework in multi-occupancy buildings. So thanks for coming, and I'll catch you on the next one. Cheers.